watching the live stream will get ready. We'll be starting in just a second. Y'all. Hey. Dr. Ong.
Hey.
So good to see you.
I flew because of this.
Thank you. Thank you.
You didn't drive, right?
I fly.
Would you like to do the honors?
I think you have to be very sure. You did 7 years?
8.5.
All right, thanks for coming to Mr. Mike Mabey's PhD Defense. He's been here 8.5 years. That's what he told me. But he got the bachelor degree from here, and he's been very active for our center and our lab in managing the various infrastructures. So today he will present his PhD thesis on forensic methods and tools for web environments.
Thank you, Dr. Ong. I really appreciate that introduction. And before we get started, I just want to acknowledge my excellent committee, particularly Dr. Ong and Dr. Dupay. Thank you so much for all your guidance and for being my co-chairs. And of course, Dr. Yao, Dr. Lee, and Dr. Zhao. I really appreciate your service and all the guidance you've given me over the years. So let's talk about web environment forensics. But first, to get started, let's actually talk just about the web. So the web is amazing. There's so many different technologies that are integrated into the web and allow us to do different things. There are things from e-commerce to social media to even work collaboration tools that make the web what it is today. And in fact, there's even been an explosion in other technologies like IoT devices that have resulted in the web's use in even more areas. In fact, as of 2008, there are now more connected devices in the world than there are people in the world. So the web is used by so many things. But with this awesome advancement in technology has also come a rise in cybercrime. The FBI has an internet crime complaint center that people can call in and tell when they've been defrauded or something like that and give the details. And every year they release a report on the complaints that they receive. And this graph depicts the number of complaints and the loss in millions of all of those complaints. And the blue line, the complaints, actually has a slight downward trend over the 9 years that it's been across these various reports. But the red line definitely does not have a decrease. So in fact, if you take a look at the average loss per complaint, in 2008, it was only about $900. But in the last report, 2016, it was almost $5,000, so 5 times higher than the first year of the report. In fact, but it actually gets even worse because when security experts took a look at the 2016 report, they looked at the numbers and they said the FBI's ransomware numbers, well, so ransomware, that's just one segment of the cybercrime that is reported in these, but it kind of illustrates an important point that the FBI's ransomware numbers are ridiculously small compared to what happens in the real world. Relatively few victims are reporting cyber fraud to federal investigators. The real cost of cyber fraud for Americans last year was probably closer to $9 billion. So the report showed $1.4 billion in loss, and security experts are actually estimating that's closer to $9 billion. So it's clear to see that cybercrime and the use of web for bad purposes it's a serious situation. So you might wonder, well, who's doing something about this? The answer is digital forensic examiners. They're the ones that are charged with taking digital evidence, analyzing it, and figuring out who was responsible, what they did, and bringing them to justice. And in order to really kind of appreciate the research that I did for this dissertation, it's important to understand first the process that digital forensic examiners go through when they have evidence. The first thing they do, of course, is seize the evidence from a crime scene. and then they go through 4 phases. The first of which is acquisition, which is basically where they just remove the storage from the device. And then they authenticate, then they take an image of that storage, which is basically a duplicate of the original storage, and that's what they work with. And that kind of protects the original evidence in case something happens when they're working with that image. So the next phase that they do is authentication, which basically just ensures that the duplicate that they made of the evidence is exact, because that's important. If you're going to say somebody's guilty of a crime, you have to make sure that that's actually correct. Then they analyze the image and generate a report of their findings of what was on that digital evidence. But if you'll look, you might notice that none of these phases, none of these actions that an examiner takes actually leads the examiner to access the web or any information stored on the web, even if the suspect's actions mostly took place online. So there's clearly a deficiency here, and to understand why, let's first talk about how a traditional program varies from a web application. When a traditional program operates, first a command from the CPU initiates that the program be transferred from the hard drive to memory, and then each one of the commands in that program is executed one by one. If that program has to access any files, those files are first transferred from the hard drive into main memory, and if any changes are made, then that happens in memory, and then the file is pushed back out to the hard drive for permanent storage. So that's how a traditional program works. The web application is a little bit different. Let's say that a user wants to use the Office Microsoft Word Online application online. Of course they would use it online because it's Microsoft Online. So what they do is they put a URL into their browser. The browser then goes to the service provider that actually has that application, that web application, and a version of that is brought down, downloaded, and then the code for that application is executed by the browser. Now, this web application, it can edit and access files, right? But those files could be in lots of different places. They could be stored in the same cloud, they could be stored on your computer, or they could be in a completely different cloud. So for example, Office 365 and Dropbox have a really tight integration, so you could have files in your Dropbox account that you're editing in Word Online, and none of that is ever actually on your device. So there's this separation between the user's device and where all this action is happening. So now that we understand how web applications function, let's talk about the forensic process for the web. Turns out there is no strategy. In fact, when I had a conversation with a forensic examiner for the state of Arizona, I asked him what he does when they get a Chromebook, and he said we don't even attempt to analyze it because they're so encrypted and so secure. There's nothing we can get off of them. And perhaps even worse, researchers from and academia really haven't produced much of a framework to even guide examiners on how to start approaching and analyzing this new kind of evidence. That is, unless you count the work that I co-authored in 2013 on web email forensics. And in that work, what we did was we took the traditional forensic process that we were just talking about a minute ago, and we augmented it with a few steps in the middle in order to accommodate the unique features of web email and allow examiners to still be able to analyze email even if it came from the web instead of being locally stored on the user's machine. So there's not much of a strategy, and that is actually one of the key forensic challenges to doing forensics in the web. So the first key challenge that we tried to address in this research is, first of all, to give examiners some kind of strategy, some way to approach this problem. The second piece is this idea of the data being really inaccessible. So if you refer back to how a web application works, all this information from the cloud isn't accessible. You can't access it. All you have is what's in the browser, and locally stored cache. So there's a lot of data and programs that you just can't access if all you have is their local machine. The third key challenge to doing forensics in the web is a lack of relevant context. So let's assume for just a second that we were able to somehow magically give a forensic examiner all of the data that a suspect had created on the web. That would be a ton of data, right? And so giving them a way, it's important to give them a way to kind of reduce that down to what's most relevant to the investigation, to what matters to what happened and what they're investigating. And that's what we call giving them context and reducing all that noise of stuff that doesn't really matter. Okay, so here's how the presentation that I'm going to give today fits together. First of all, I'm going to talk about our framework for web forensics that gives examiners a way to approach the problem, and then I'll talk about how we apply this framework first to identifying the data that's on an encrypted WebThin client, and then also some techniques for doing forensics for enterprise WebThin clients. But let's first talk about this framework. Sorry, my mouth is really dry. All right, so to kind of frame the problem and help understand the motivation behind all of this, let's pose a hypothetical scenario involving a user, Mallory. All right, so Mallory is an employee at some fictional company, Acme Inc., right? And but the thing is, she's actually doing some stuff on the side, creating a new business that she calls Malco. This is a conflict of interest. It's against her company's policies, and it's just not a good thing to be doing. And she knows this, and so she behaves accordingly, right? So when she's doing work for Acme Inc., she assumes one persona that we're going to call persona A. And when she assumes this persona, she always uses the Firefox browser. She does use her company Gmail account, and with that account, she's created new accounts in Trello and Facebook. Trello for collaborating with her coworkers, and Facebook for interacting with customers. But when she assumes a different persona that we'll call persona B, she has a different set of actions that she takes. She always uses the Brave browser, and she created a new email with Proton email, and with that she created accounts at Evernote and Facebook. Evernote to keep track of stuff, and Facebook to kind of interact with her Acme Inc. customers and gauge their interest in this new company that she's creating. So when the examiners, administrators at Acme Inc. figure out what she's done, they're going to take a look at her computer. They're going to take her outer hard drive and analyze it. All they'll find is some cookies, maybe some passwords in a password vault. That's it. Because all of her actions took place online. Just like we talked about earlier, there's not much stored on her machine that actually indicates what she did. So, so the examiners can't access it unless they have some other way to get at it. So using that scenario, there's 5 key challenges to doing forensics in web that are unique to the web. The first is complying with the rule of completeness. When examiners are analyzing evidence, there are certain laws that they have to abide by, and one of them is the rule of completeness, which basically says that the evidence that they collect and analyze has to tell a complete narrative of what happened, meaning there are no significant omissions, and the evidence is not misleading as to what actually happened. So that's the first challenge that we have to address. Second one is associating a suspect with online personas. In this case, examiners need to show that both persona A and B were created by Mallory, and she was the actual human responsible for everything that was done by those personas. The next one is gaining access to the evidence that's stored online. That's pretty obvious. Nothing is really stored locally, so we have to gain access to that online data if we're going to show that she did anything with malintent. And that's why her name is Mallory, by the way. The next challenge is contextualizing this evidence. in terms of content, which I call thematic context, and as well as time, which I call temporal context. These two forms of context are very important for a forensic examination. The final unique challenge for web forensics is integrating tools and to perform advanced analyses. What I mean by this is that because the web is so vast and the services involved in the web are so diverse, it's unreasonable to expect that any one tool could do everything that we need to do when analyzing, when doing forensic analysis in the web. So we have to have a way to have tools interoperate and work together to do more advanced analyses. And that brings us to our framework for actually addressing this problem. Our framework has 4 components, the first of which is evidence discovery and acquisition. The main objectives of this part of the framework are 1, to connect the suspect to the persona, and 2, gain access to the evidence from the web services. The second part of the framework is analysis space reduction. And by this, what we mean is specifically giving the examiner thematic context, so figuring out what is most important for them to spend their time on and analyze. The next one is timeline reconstruction, which gives temporal context to the evidence. And finally, structured formats. This is one of the most important parts of the framework because this is what bridges the other 3 components together. Because it separates out the tool from the storage format, and that's what allows different tools to work together, because the storage format isn't bound directly to how a tool operates. So at this point, what I'll talk about is first what each component looks like when a forensic examiner is doing that part of the framework, and then also some of the research challenges that still exist for that component. So first, let's talk about evidence discovery and acquisition. The way that an examiner would do this part of the framework is, first of all, well, there's the 2 parts, discovery and acquisition, so they need to discover the evidence. What I mean by that is they need to search the storage devices that they have in custody and look for some service credentials, and then derive the corresponding service. And what this does is it gives the examiner an idea of where to get the data and an actual way to authenticate to that service so that they can later access it. And in Mallory's case, these cookies would then give access to give the examiner access to the various services that she used. The next part of the process is acquisition, and this is basically just finding a way to download or at least access all the information that's stored by that service provider. Some challenges to this part of the framework are, first of all, the volume of data. The web stores so much data that if we were to get all of it like we talked about earlier, it would just be overwhelming. And downloading that or even sifting through that is a huge task. Also, the boundaries of data are really ambiguous in terms of geography and ownership, and that just presents a challenge from the examiner's perspective. Also, the user may have a lot of different accounts, which just means that it's difficult to discover all of them and determine which ones of them are relevant to the investigation. So that's F1. The next part of the framework is F2, analysis space reduction. And what an examiner does here is, well, they can take a couple different approaches to reducing their analysis space. The first one, and more traditional one, is classification. So in this, an examiner basically puts labels on different forensic artifacts, indicating their subject or theme. This could even just be like a keyword search for a plain text document. The words in there are effectively labels. But once those labels are in place, the examiner can then filter for the relevant labels. So again, keyword search would bring up those artifacts that are relevant. The other technique to doing analysis-based reduction is identification. And what I mean by this is basically just determining what the evidence is. This is really only applicable in cases where the evidence is encrypted, but we'll talk about an instance of where that actually became useful a little later in the presentation. Some challenges to this part of the framework is, first of all, false positives, or in other words, labeling an artifact as relevant when it's not relevant. Since what we're trying to do is reduce the analysis space down to a smaller size, if we have false positive, what that means is that we've suboptimally reduced it, which just means that the examiner still needs to spend more time with those things that aren't relevant, but doesn't adversely affect the investigation itself. Conversely, false negatives are unacceptable, because this is where you label an artifact as not relevant when it actually is. The reason why is because false negatives obscure relevant data from the examiner and may alter the outcome of the investigation, such as saying that someone's guilty when they're actually innocent. That's not an acceptable outcome. In fact, exculpatory evidence or evidence that suggests innocence is particularly prone to false negatives because it's difficult to identify. And even just the lack of evidence could be exculpatory in itself. So doing this in an automated way is pretty difficult. All right, the next part of the framework is timeline reconstruction. And what an examiner does for this part of the framework is they first just collect and combine all available time data, which requires some acquisition tools and methods. And then they remove irrelevant data. And what I mean by this is that particularly web services have a lot of extra metadata. So think of Google Drive. Google Drive actually stores a ton of extra metadata fields that normal file systems don't support. So all that extra metadata might be helpful, it might not. It's important to filter out those things that aren't. But also there might be some data outside of the time frame of interest. But once you have that information and you've removed irrelevant data, you need to establish relationships between entries by doing chronological ordering and correlations. So in the instance of Mallory, if she started creating Malco at one point in time, everything before that isn't going to be relevant, and you only understand that by doing timeline reconstruction. And you can kind of get this window of time that you're really interested in when you're examining the evidence. So some challenges to timeline reconstruction is, first of all, there already exists some timeline reconstruction tools for forensic analysis, but they can't accommodate the web for a reason that I just stated earlier, that those extra metadata fields that Google Drive and other services store, they're not expecting them. Even if they were really helpful, they can't leverage those to do the timeline reconstruction. Also, there's a large variety of types and formats of logs and time information, and being able to parse those and make sense of them and put them in chronological order is just difficult. Especially when it comes to like IoT devices where the manufacturer may no longer be around. That just presents a lot of extra issues there. Also, the issue of time data inherently brings up a challenge of reconciling time zones, especially because you can't assume that everything's in UTC. So it just makes it more difficult. And having that time offset could be critical in the outcome of an investigation. All right, so the next part of the framework is structured formats. And for this one, actually, the examiner should never have to directly do anything with this part of the framework, because its intent, again, is to help tools interoperate. So forensic examiners don't have to do anything with it. But there are some substantial challenges that still remain in this area. First of all, there are 3 requirements for any kind of structured format for forensics. First of all, it has to be a precise representation of the original evidence. This is just part of forensics because, as we talked about earlier, when an examiner acquires and then authenticates the evidence, they have to ensure that it's precise, that it's exactly the same as the original. It's the same idea here. And so it has to be a precise representation of the original data. Also, there has to be a method of verifying that some data that's in the storage format conforms to some specification, and that in order to do that, the specification has to be published, it has to be available for people to take a look at and use. Another big challenge to using structured formats is that there are always going to be trade-offs This could be something as simple as heavily supporting the file systems used by one operating system and not another. It could be just trying to keep the specification concise rather than trying to support everything in the world. That can be a hindrance to it being efficient. So that's our framework, and to kind of summarize, it has 4 components, each of which directly address the unique challenges that we talked about earlier. And probably the most important thing that it does is it gives examiners a way to approach web-based evidence, which is kind of a new domain for them. And it also provides examiners with previously unknown data and relevant context. And if you remember earlier, we said that having a method to approach the problem, getting access to previously unknown data, and giving it relevant context were the 3 key challenges of web forensics itself. So we've addressed that with this framework. Also, the framework is non-sequential in structure. This gives examiners the flexibility to kind of do one part of the framework or another as the evidence needs them to. It's not rigid. They can go from one part to another. And that flexibility also means that this framework can fit within existing forensic processes. So the traditional forensic process can accommodate this because it's so flexible. Yeah?
So there are 4 major rules for forensic analysis.
Yes.
Could you explain why the completeness is the major concern in your work?
So the 4 rules of evidence, let's see, so you're testing me. Completeness, man, I'm drawing a blank here.
You should know.
I should.
It's your work.
But of course, when it's hot and I have a bunch of people staring at me, it's a little harder. It's in my dissertation, man. Let's see. So we have authenticity, admissibility, completeness, accuracy. Yes. So admissibility is more about how the examiner handles the evidence and the processes involved in the tools. So that doesn't really apply to the framework because this is guiding them on how to approach the problem. Completeness, it does address that, so we've talked about that. Authenticity is where we try to create a direct link between the suspect and particular actions that happen. And so this actually helps them by giving them previously unknown data and relevant context. And so it does address that, not directly, but it helps facilitate accuracy?
The last one, yeah.
Okay, so the last one is accuracy, and that refers to the function of a forensic analysis tool, that it functions as expected and predictably. So actually, the structured formats of the framework help facilitate that, because by having a standardized structure for storing information, you can compare the output of one tool with another. So even though this doesn't implement any tools that would need to have accuracy, it does help facilitate accuracy, which is one of the rules of evidence.
Really?
You don't believe me?
Accuracy is related to your evidence, not to your tools or framework. So for example, I provide evidence to you, like all the artifacts here and there, and you have to somehow prove that all the attributes are reliable. Right? So that is the notion of accuracy. So somehow your time reconstruction can cover both that authenticity and accuracy too. Right? But you just mainly brought up the completeness issues. So that's I'm just asking from curiosity, because time reconstruction they can cover the connection between evidence and potential like suspicious like persona might be the right term in your work, and also based on the time construction, trying to bridge some gap between all the evidences.
Yes.
It's like a reliable evidence they can present to the court, something like that. So that's what I'm asking.
Okay.
Because
No, that makes sense.
maybe you can address that issue in your motivation later. Yeah, there are 4 major rules, and some rules can be covered by your frameworks, some of the tasks, but major concern was completeness, because we'd like to make sure all the evidence are there.
Okay.
But even
No,
though
that
you
makes
mentioned
sense.
4 rules, that motivation didn't mention why the completeness was picked, so that's why I'm asking.
I see.
All right.
Okay. No, that makes sense. All right. So moving on, we just talked about the framework, and now what we're going to do is talk about how we applied it specifically to identifying the data that's on an encrypted web-thin client. And in this part of the work, the parts of the framework that we leveraged was F1, F4, and F2. We didn't address F3 for a reason that will be a little more more apparent a little later in the presentation. So we want to identify the information on a web-thin client. And actually, this part of my work, I gave more details in the proposal defense, so I'll just touch on it really lightly here, unless there are specific questions that I can address. So let's think back to the scenario with Mallory and everything that she was doing. And let's consider how things might be different for an examiner if Mallory was using a Chromebook with all the crazy encryption that the Chromebooks use and how locked down and secure they are. Because we can't access anything from that encrypted, the encrypted device, does that just mean that the investigation can't proceed forward with this kind of device? No, actually, what we did was we came up with a way to still be able to identify the information on one of these encrypted devices. In fact, so we were able to extract residual evidence that's stored by Chrome OS without relying on accessing any of the user's data online or breaking the encryption or extracting encryption keys from the system. We also didn't circumvent any of the security features built into the operating system. And these three assumptions that we built our work on are important to make them usable in the general case, which is important for forensic examiners. And what we did was what we wanted to do was to determine which extensions and apps users had installed, and this goes back to trying to tie what the user did and where their data is. So to just kind of summarize what we were able to accomplish, we created a set of tools to enroll and identify extensions, then export the identification results in a structured format. We also made sense of the metadata on an encrypted device without breaking the encryption, without loading a custom operating system, which is a common technique in forensics to load a custom operating system. And we were able to narrow down the scope of the forensic analysis by doing this, and thereby take some first steps toward comprehensive web-thin client forensics. And this was a really cool project, and particularly the technique that we used to enroll these extensions by leveraging a mathematical formula to represent them. It was really cool. So we just talked about how we were able to identify extensions installed on encrypted web-thin clients. Now we're going to talk about how we applied this framework to enterprise web-thin clients. And for this part of the work, we used F1, F2, and F3. But we didn't really use F4. What I mean by that is that we didn't create any new structured formats for this part of the work. We used them, but we didn't create them, and you'll see why in just a second. So there's a new trend in enterprise IT to really start to kind of simplify the administrator's job and the administration as a whole. And one increasingly popular solution for doing this simplification is G Suite and Chromebooks. In fact, as of January, Google reported that they have 3 million businesses that pay for G Suite. And actually, on top of that 3 million, there are 70 million users of something called G Suite for Education, which is a version of G Suite that Google gives to schools free of charge. So schools love G Suite and they love Chromebooks. In fact, Chromebooks have really started to dominate the K-12 market. As of just 2016, they accounted for 58% of all computer sales to the K-12 market. Now, if you consider for a second that Chromebooks didn't even exist before 2011, this is huge. This is a big trend. And these schools are using G Suite for Education to manage these devices. So these two services really go hand in hand. Now, one of the key things that makes it so easy for organizations to administer their IT systems with G Suite is because of the G Suite dashboard. I'm not trying to sell you on G Suite or the dashboard, but it's important to understand what features it has to understand the next part of my research. So here's what the dashboard looks like. It allows administrators to do device and user management by adding users, changing their permissions, enrolling new devices, but also what they can do is they can force install an extension on all of the enrolled devices. So if there's a particular extension that they need installed. It also shows user activity such as login attempts, like when I mistyped my password and I wasn't able to log in successfully. It shows that in the log. It also shows some security parameters such as the number of external and internally shared files. But it also gives very detailed information about all these enrolled devices, such as the recent users on that device, the active times, and even very specific hardware information. So with all this information, what does an administrator, if they needed to do forensics on a Chromebook that they have enrolled for their organization, what would that look like? Well, from the Diebling project, one of the things we learned is that the data on a Chromebook is really encrypted. They use very strong encryption techniques to on not only the user-created data, but also the system logs that are stored in /var/log. So the normal Linux system logs aren't accessible because they're encrypted. So that kind of leads to the question, because we have this G Suite, could we use that as a proxy for the device to still be able to do forensic analyses even though this device is encrypted? Well, let's compare our framework with what we have from G Suite. First of all, F1, Evidence Discovery and Acquisition. G Suite gives us data directly accessible in the dashboard. So we have that. We also have analysis space reduction because on most of the report pages, you can do filtering and searching that allow you to really find what you're looking for. Also, structured formats. A lot of the data that's available in G Suite is exportable in JSON. And for the purposes of my research, JSON was good enough, and that's why we didn't create a new structured format for this part of the project. But you'll notice the thing that's missing is timeline reconstruction. So that's what we focus on because with all of the information that G Suite offers, there's no way to do that in the dashboard or even with the data that they give you, because there's actually missing pieces of data that make it impossible to do a complete comprehensive story reconstruction. So just as a kind of quick refresher on what timeline reconstruction is all about, it's a forensic method for improving the temporal context. You gather and combine all the data, you remove irrelevant data, and then you establish a relationship between these entries. And this really helps examiners comply with the rule of completeness. There are 4 key questions that you have to answer if you're going to properly reconstruct a timeline. Yeah?
Which can also help improve accuracy, right?
Yes. Yeah. The first of these questions is who used the device? And when did that individual use the device? What did they do while on the device? And what files contain information that could be really important to the investigation? Yeah.
Can you define what those words mean for people who are
yeah, I'm sorry. Inculpatory and exculpatory mean, respectively, inculpatory means it suggests guilt, and exculpatory suggests innocence. So if we take a look at these 4 questions, the first 2 kind of are really closely related. In fact, they really pertain to linking a device with a user session. And what I mean by user session is the period of time between when they logged into the device and when they logged out of the device. So the whole time that they were using it, that's the user session. The second set of questions, the last 2 questions, the answers to these will link the user session with specific actions and activity. So now that we kind of know what we're looking for, let's talk about what kind of data G Suite does offer that makes it that helps us to answer these questions. The first is about devices, specifically enrolled devices. We can get a lot of information on any enrolled device, but the most important ones are the serial number and the MAC address because those uniquely identify that device. The next one is user session information, so specifically login data. So G Suite, as we mentioned earlier, it records the time when any user attempts to log in, if it was successful, and the authentication method, all of that. The most critical piece of information from here are the time and the actual email address of the account that they were trying to log into, because this will help identify the individual. The third source of information is we use Google Drive. Now, we could actually get similar information from Gmail or Google+, but for this initial research, we just focused on Google Drive because it mimics and is very similar to traditional forensics and analyzing files. But we've got a lot of metadata that's accessible from Google Drive. The most important of which is the created and modified times, because that indicates the user's activity. So if we tried to combine these different sources of information, we would and link them back to the questions that we're trying to answer, such as who used the device and when. We have information about the device. We have information about the user, but we can't directly link them together because we don't know which user used the device when. And as far as what the user did on the device, we know the login time, but because we don't have a second parameter of their log out time, we can't definitively say that this activity took place during that user session because we just have like one bookend. We don't have the other one to really kind of give that second parameter. So because we have these gaps in information, it was necessary for us to turn to another API. This actually comes from the Chrome browser, which Chrome OS, the default browser is Chrome. So it's available in Chrome OS. So there are 3 pieces of information that are essential to gather from using the Chrome API. First, the email address of the signed-in user, current time, which allows us to infer the login and logout time, and the MAC address of the device. Now, you can't actually directly get the MAC address of the device, but because Chromebooks self-assign their IPv6 address based on the MAC address, using techniques that are actually discussed in RFCs, we can derive the MAC address of the device. Now, with these 3 pieces of information, what we can do is actually link all of these, the MAC address, email address, and the user session, which when we put it in the context of the other information we have, we can suddenly link these 2 pieces of information, the device and the user, and we can link the person and their activity because we have this email address associated with the login and logout time. So putting everything together, we can link everything. So we have information about the device, the user session, and their activity all linked together because of this 4th source of information that we call beacon. And we actually we implemented this beacon, and it'll be clear in just a second why we call it a beacon. And what we did was we implemented it as a Chrome app, and then we used the force install feature of G Suite that we were talking about just a few minutes ago to make sure that every device in the organization has it installed, which is important because it's part of a forensic process. So we need to be able to rely on it being present on the system. Now this beacon, what it does is it collects information, the information from the Chrome API that we were just talking about, and then it transmits it at a custom interval to a server controlled by the administrator. And that's how we collect the information that we need to be able to link all of that information about the timeline. Now, let's assume that you are an administrator of one of these 3 million organizations that uses G Suite. If you're going to install this on all of your users' devices, what's one of the biggest concerns that you have in terms of people being unhappy that is there? Battery life. So what we did was we performed an evaluation on how this beacon app affected the battery life of a Chromebook. So the complete experimental details are in my dissertation, but these are the high-level conditions that we tested. Basically, we minimized everything else that was running on the Chromebook and minimized battery usage in all other areas, and then we timed how much battery, we measured how much battery was used in a 10-minute interval by polling it every 60 seconds. Sorry. The ping period is how frequently the beacon was trying to send the information to a server. Okay, so first it started with just no beacon installed, Wi-Fi off, and measured how much of the battery the device used in 10 minutes. And it used 0.46%. Then I turned on Wi-Fi to see what it did still with no beacon installed. And it used 0.48%. Then I installed the beacon itself, and it used 0.51%, which is only an increase of 0.03% of battery usage in a 10-minute period. But one interesting thing that I noticed is that when Wi-Fi was off, even with beacon installed, the battery usage was really negligible. And in fact, the battery usage really closely matched when the beacon wasn't installed. Yeah?
There's a small point. It's not 3% increase if you have 48% to 51%. It's 3 out of 48.
You're right.
Yeah.
But
You have it
point
next.
oh, it's what?
You have it next, just like.
Yeah. So the overall, when we extrapolate this to the life of the battery's charge, it does come out to be 6.25% overall. But you're right. It's not 0.03% of 48. It's 0.03% of the battery's capacity that it was used. That's an increase. But you're right. Thank you. So the fact that the beacon's use of battery was negligible when Wi-Fi was off tells me that the main consumption of power comes from when it's attempting to transmit the data, which is something that we can fine-tune in future iterations of this proof of concept. Okay, so now that we have all this data, let's assume that an administrator is trying to reconstruct their timeline. They have Beacon that's pulling in all this information. What do they need? They're going to end up with a lot of data. And so what we did was we actually wrote another tool to, yeah, go ahead.
I have a question, sorry to interrupt.
That's fine.
I'm not familiar with the Chromebook architecture, but I was wondering if the users can deactivate the beacon app.
They cannot. Yeah, so G Suite, that feature of force installing is out of the user's control. So they can't disable it, they can't uninstall it. So the administrator can be ensured that it's always going to be installed if they specify that it needs to be.
Another assumption perhaps would be that they, since G Suite allows administrators to regulate devices, only the devices having Chromebook should be the ones the employees should be using, right?
I'm not sure what you mean by that.
If you use your personal laptop, does it have Beacon?
No. Yeah, so you're right. Only the enrolled devices would have that force installed extension. So even if they have if they log into their personal computer with their company, with their organization's email address, if they log into Chrome, it's not going to sync that particular extension because it comes from a group policy which is a different, which is enforced differently by Chrome
So
itself.
as an administrator, you can actually forbid other devices on PC.
What do you mean by forbid other
Let's
devices?
say you just want the employees to use the Chromebooks. The company.
They can use other devices. There's no restriction on that.
You can have an organizational policy that says you cannot use your own devices, you have to use our devices.
Right. That's what I'm saying, because if you use your personal laptop, then you can bypass this, right?
Yes, but it's hard to steal corporate data that's only accessible from the corporate infrastructure on a corporate laptop from your own device.
Okay, we good?
Yeah, we do.
All right.
Sure.
So now that we have all this data to reconstruct the timeline, we figured that this would be a ton of data for administrators to sift through. So what we did was we implemented another tool that pulls all this information together and then creates a visualization of everything. So using actually a heat map, which is shown in this animated GIF here. So you can see that you can select predefined periods of time. You can scroll around in the preview. The activity is separated into hourly segments, giving you an idea of the user's activity throughout a normal day. It also uses an exponential color scale, which gives this visualization really important visual contrast to periods of unusually high activity to really highlight those out for the examiner. Okay, so we've applied the framework to identifying data on encrypted web-thin clients and enterprise environments, and actually these three areas we have publications on. The framework actually was just accepted to a conference that'll occur in January, so just in a couple of months. And also the identifying extensions on Chromebooks was published in DFRWS 2016. Now the forensic timeline reconstruction, that we actually plan to submit to S&P 2018. So really quick here. And also a fourth paper that we talked about earlier in the presentation, the web email forensics paper, that was a big inspiration for the development of our framework. So the main contributions of this dissertation are, first, I created a new framework that provides examiners with a way to approach this new domain of web environment forensics. I also developed a novel method and set of tools to identify extensions that are installed on encrypted web-thin clients without breaking the encryption. And finally, I reconstructed the timeline of user activity on enterprise web-thin clients using APIs as a proxy for these encrypted devices. Also, while I was working on my PhD, I had a number of open source contributions this is actually not a complete list. This is just the most significant ones. And these ones on the top left, this is what comprises dbling and Gripper, my timeline reconstruction tool. Also, the ICTF framework and Python Vagrant were actually part of the paper that Eric was the lead author on for the ICTF that we did. And then also Crumbler was a key element of the web environment forensics paper. Now here's a timeline of my PhD. I've been here so long, it kind of feels like back when I started, I was just like a little kid, just having fun on a computer. But I started in August 2011, then I had a clump of papers published, and then I had a couple kids, and then I published a clump of papers, and here we are today. What's that?
Expecting another one or
I was
not?
gonna say,
Not
extrapolating into the future.
not
is the trend.
expecting.
Planning.
But planning,
Oh.
definitely planning, yes. And then here's a list of my publications, and with that, I'll take any questions.
So you motivated with Valerie's case, but you didn't actually go back.
I tried to. I forgot to tie it in more times, but I meant to. You're right.
Okay, so can you actually elaborate how your tool can be used for that scenario?
Sure. So specifically, okay. So if we make the assumption that Mallory is using a Chromebook, the first thing that we would try to do is identify which extensions she had installed, because it might be possible that she wasn't syncing what extensions she had installed, so that might not be visible in the G Suite dashboard. But then to kind of identify what she did and what her activities within the Google suite of productivity, we would use Gripper to kind of create that timeline. Now, the reason why I gave that restriction is because obviously Google doesn't provide you access to other services. So Gripper is designed specifically to work with Google's APIs because those are the most significant in terms of managing these devices and collaboration within the organization from a G Suite perspective. So yeah.
And so what is the particular question that the examiner wants to, so for this scenario, do they want to know that person B is Mallory? Is that the thing that they want to get, or is it something?
So to kind of frame my answer, I think it's important to kind of put it in perspective that before this, no one's been able to do any kind of forensics on these web environments. So this is kind of an initial first step. So that first step is to identify what services she was using. And the only way to do that is to kind of collect any residual information from the device from what is synced to G Suite. And so it's not fair to kind of compare what I've been doing and traditional forensics, which can do a ton of things on a regular desktop or laptop. They can analyze a lot of information and come up with conclusions. But these are kind of first steps in this area. So by just giving the examiner this reconstructed timeline and indication of where some of her most of her activity took place, that's going to kind of get them going in the right direction.
So information.
Yeah, so maybe like, could you, so if we envision a scenario where we have Mallory doing this on a Chromebook, and let's say it's encrypted, and then the company gets it. Let's say before your work, what would happen, and versus post your work now, what can happen?
Yeah. So I think at the beginning I told the story of I had a chance to talk with one of the forensic examiners from the state of Arizona. I asked him what they do, and he just said we don't even try because there's no way to get that information. But with my techniques, we can actually get some kind of information off of that. So it's a step in the right direction at least.
So you say they cannot get information
Off of the encrypted device. Yeah.
due to encryption.
Yes.
Right?
Yes.
Okay, you finish. I have a question about that.
Great.
So you're assuming that by providing this information, human can find out more information from there, right?
Yes, because
But many of the things that you're doing seems to be reasoned in a simple way so that you can actually drive more information. That is sort of, I mean, those things, timeline, and those are all very good knowledge. You
Yes.
just need to derive some conclusion from this, right?
yes. So that's one reason why I put such an emphasis on the structured formats, because because right now it's just these tools that are doing some rudimentary analysis on the evidence, right? If we can then put this in a structured format, then the hope is that in the future, there would be some really advanced analysis tool that can take that and take it a little further on behalf of the user, of the human operator.
You're in the class, right? You know what I'm talking about.
I do.
This is a good information sources, right?
Yes.
So,
Yep.
with some, I mean, I don't think it's a major effort that you have to do. So, I mean, I'm not saying that you have to do. I mean, I know this is targeted for this one direction, but if somebody else is working on this, that's definitely worthwhile to do because there's a lot of information that you can relate to. So you can find out some link detection or some prediction or some classification.
Exactly.
Not the thing, but based on this evidence.
Yeah, and actually, I didn't bring it up in the presentation, but in my dissertation, I talk about how the hope is that, well, there are other forensic researchers that are working on doing some cross-evidence correlation, do some really advanced analysis. But what I wanted to do was kind of explore this new area and at least give us the information from the web, because all that all that correlation of evidence is just on traditional storage mediums. So we have to get that first, and then we can kind of tie into these other advanced research areas. So, yeah.
We discussed that issue during our, I think, his proposal defense regarding correlation and reasoning. But in order to do it, I think we need to get the evidence first.
That was
So
the
I
key
think
problem we
that
ran
was
into.
the,
There's
first
not
step.
even
But
a-
obviously,
Well, from the
Right.
AI point of view,
Yeah.
this information, getting the domain information is actually very difficult.
very hard.
Okay, so if you create this thing, it's a good resource for us too.
Absolutely. So
Great.
that is the future.
Can't tell you how happy I'm hearing you say that.
Again, the future work. I think you didn't mention
Yes.
future work. Maybe that's why I think.
Yeah.
Dr. Lee, I think, brought up that issue.
Yeah. Oh yeah, Dr. Yao, yeah.
Well, I ask you specifically on one thing, but later on I have a much broader question.
Great.
But that probably in closed session, okay?
Okay, perfect.
You talk about some of the information that you cannot get because encryption,
Yes.
cryptography, okay? So, your method, how much information you can get? You know, like this information is encrypted, and you say you can get it wrong. Whether you can get 100% of the, or half, or 10%.
So when I started working on the deebling project that identifies the encrypted information,
Yeah.
I wasn't sure what I would be able to get. But what I discovered was that Chrome installs extensions in a very specific place. And the files of an extension don't change when a user uses that. All the user data is stored elsewhere in the file system. So because the extensions were always located in a predictable location, in terms of like the depth into the file system and certain characteristics of the file system, I was able to narrow down the possibilities of where those are installed. So that's what allowed me to be able to identify these installed extensions. I never tried to identify not the content,
Yeah.
just using the metadata of the encrypted files. I don't even attempt to recover user data because it doesn't have a predictable structure. It doesn't have a predictable location or size or any of that. So that's why we needed this this G Suite approach to kind of complement that information that we couldn't get from the encrypted device.
Okay. Well, yeah, that most significant. Well, you have a lot. You have overall. You have the framework, right?
Yes.
And then in the framework, there are many tools and methods you have, and some are just a primary implementation, not
Yes.
a main research. Do you consider what you just described one of the most important contributions?
I would say that the framework is the most important contribution.
Well, framework,
because
the overall structure. Inside the framework, there are you have a slide list of many tools, many methods, right?
yes.
Among those methods or tools, which are the considered important contributions? Some of them, a good idea, you implement, not much research for them, right? Well, which is also important, but not if I just keep implementing, that's not can be considered original research. It's an original development.
Right.
Do you understand my question?
I do. I'm not quite sure how to answer it though, because if you're going to exclude the framework,
No.
Within framework.
within the framework.
What? You have show me the previous slide you had shown. Yeah. The last
Which-
slide. No, not this one.
Which
Yeah, the one.
back
Next one.
here?
Next one. The list of tools you have.
Open source contributions.
Well, that's only for open source.
Right.
But you also have others that are not open source.
So this is what he contribute to the open source community. It's not from the open source.
Oh,
You
no,
made it.
I understand. All your tools listed here,
Yes.
what tool you consider you did? It's not as a, hey, this is the only part of it.
Okay, so let me answer that by clarifying one thing. So this ICTF framework, the Python Vagrant, those are the only two projects that aren't mine, that I just made contributions to. Everything else are things that I created.
Fine, that's what I asked you.
Yeah.
All these, which one you consider major contribution besides the framework, the overall framework?
I've got to say Deebling because
Which one?
Deebling, the first one that identifies, that identifies the encrypted the data from an encrypted device.
Okay, so the encryption, that kind of thing, it's not a major thing.
Well, okay, debugging is related to the encrypted.
Debugging
evidence.
is the
That is the
same
major
thing.
one.
Yes.
So he open sourced his implementation to do this,
Okay.
to identify information even on an encrypted Chromebook.
That was the kind of beginning of this work. So he tried to get evidence from encrypted.
Okay, let me go back to my previous question. You get around the encryption, not can find the content.
Right.
But due to some error. Can you summarize what's the end result you get from that technique, which mostly useful for forensic application?
So let me see if I understand the question. So when I'm getting information, getting around the encrypted data, what's the most important information that I can?
Yeah. Well, the end result you get it, use your method, you find out something about the encrypted data, right?
Yes.
Not the content.
Not the
if
content.
you content, then you know everything.
So I would say that
Do you have slides from Deebling that you can
I sure do.
maybe that?
Me.
Well, this is very important because find out how powerful or useful your method is. If it's
So-
very good, the FBI will ask you.
Let's not get into that. That's a long story.
We don't like that.
Yeah. Okay. So
No,
this
it's just
this is actually what I would consider the most significant contribution in regards to your question, which is the mathematical representation of the extension. So we figure out exactly what the structure of an extension is, and we do these computations on it, and it's represented as a 7-dimensional vector. So by representing this static data, well, static when it's on the machine,
Yeah.
by just 7 numbers, that's pretty, actually,
And these
kind
are
of derived that from another work. But
all numbers that you can get that survive encryption, right? So
that
you
are
have
worthwhile. to-
high-level
yeah.
metadata that survives post the encryption process.
Yes.
And then what do you use this as output for? So what's the output here? Can you walk us through?
Yeah. So the so what I do with it is I put it through this this process of sorry, let me collect my thoughts. With that information, a forensic examiner can then identify these extensions because they have this number, and only by analyzing the metadata of the files on an encrypted device.
So what about this way, Mike? Let's say the FBI gives you a Chromebook. You run your method on it. What do you tell them back?
Oh.
And how is that useful to them?
Yeah.
Final results.
Yeah, so I'm sorry. So this actually shows that. So in this part of Deebling, we're exporting all the analysis results in a structured XML format, and it specifically gives them what extensions matched the best in terms of this mathematical comparison, and it's exported in a way that could be ingested by another tool. Does that answer your question?
That's his question.
Your question? Everybody's question?
So it would output then, so to go to the scenario, you would say it looks like these applications are installed, right? Evernote or Gmail or Google Photos, so that then the FBI can then go get a warrant and subpoena
yeah.
one of those companies because they know that this hacker has an account on one of those sites.
Not an Apple.
Exactly. If they don't, well, no, we don't even.
We are not working with Apple.
No, they would still
No, I
probably
say
have to respond
FBI,
to a
Apple
subpoena
refused,
Yeah.
but-
if you had an Apple. I mean, if you But the point is the FBI can't just go subpoena random companies,
No,
right?
no,
They need that link between this device was owned by this hacker,
Okay.
and we can,
No, I understand.
Mike can fingerprint and say this application was installed.
Okay. So when you discuss this, be clear. It's a usually
Well-
people say you get it wrong, you decrypt the whole thing.
Yeah.
Right, yeah.
Okay.
Good point.
Any questions from audience?
What? Yeah.
18 months ago in my company, we had a Mallory. he was a Mallory. And he was downloading very confidential trade secrets from our company and was creating a similar company. We're now over $1 million into litigation and trying to track down what he's done and what was downloaded. With this system in our company, would our IT department be able to identify what files he exported and what happened to those, or I don't know, because I see this as, man, I wish, I have a million reasons to wish that this had been around a little bit sooner, but I guess, is there a version of this for me in my scenario?
So the sorry, I'm getting a little lightheaded. Hold on a second. Didn't have lunch,
I
so
didn't mean to
no.
do the light.
It's fine.
Take a
It's
deep
fine.
breath. So what kind of devices are you talking about? Chrome notebook or just regular?
So we've got company computers.
Oh,
that
okay.
we have.
They're Windows.
Windows computers.
Yeah. So this is specifically for Chromebooks. So that would be the first hurdle. Is
But I think that's
And everything was stored on the Google Drive.
oh,
okay.
well that would be yeah.
Then
That,
you can.
were you using? Was it his personal Google Drive or was it
No, it was
like
the
company?
company's Google.
So they're using G Suite. So
Okay, yes.
that's great because actually this would directly apply to your work.
Okay.
It's not like I have a vendor-ready product to give you, but
That's not what I'm asking for, but we might want to talk later. So is that something that, because of the fact that we were using a company Google Drive and he was exporting files, that we could have busted him on?
yep, yes, yeah.
And I think that's key to what Mike's been looking at, is looking at this and saying like, okay, if an event did happen, is there actually enough data here to link some things? And we found out in the Google G Suite plus the Chromebook case, the answer is no, because there's not enough, you can't link this data together. And so that's why he had to develop the beacon to say, if you proactively install this, then this is good. But I think part of what he's doing is trying to move forward and get people and companies to think about these things.
Yeah, and I know that we've spent so much in litigation trying to nail him down on the fact
Right.
that this is happening, it's hard to gather that evidence.
Yeah. Well, Waymo's actually going through the same thing. Their litigation against Uber, it's very similar circumstances. So you're not the only one. I know that doesn't give you your $1 million back, but
Oh, we'll get it somehow.
Even though he was not talking about cloud forensics, but eventually it'll be the good, some kind of cornerstone for cloud forensics.
yes, definitely.
Everybody is using cloud these days. Think of autonomous vehicles; they will use cloud eventually.
But the forensics process isn't keeping up, right?
Right.
So that's why we need
Yeah.
things out in front to think about frameworks of how to approach these problems.
All the IoT devices will use cloud as well, so
Yeah.
it's very important work. Any other questions?
Hans, yeah.
Yeah, so do you have any speculation on what kind of response this might get from Google? So it's very Google oriented. So
It is.
it seems like, or at least my understanding is that Beacon has to predate the relevant behavior in order to identify.
It does.
So it seems like it could go one of two ways. One way is they could see that as a valuable service that they could offer to their G Suite customers and basically bake Beacon into the product offering. Or it could go the other way and they could say, oh, well, we don't want people to be able to do this. Only we want to be able to do this. So we're going to kill this API access and block the behavior.
Also, privacy issues there too.
Yeah, well, I mean, as far as like them killing off the API, I'd be really surprised if they did that because it's not really Google's modus operandi. Like that's not how they work. They change their APIs, but they don't really cut them off. So I think if they were to look at this and say, this is a valid point, what I think they might just do is start collecting a little bit finer grained detail that would make Beacon unnecessary. And chances are they have that somewhere in their vast databases of who knows what, but that's just not available through the API. It's hard to tell from an outsider's perspective, but.
So then I guess my follow-up question is, you mentioned that a lot of the stuff's encrypted, like /var/log.
Yes.
Is that encrypted with a user key, or is that encrypted with a Google key?
So on Chromebooks they use eCryptFS.
Okay.
So it's a file individually. Each file is individually encrypted, their name and their contents, but /var/log is actually a little bit different because they use the device mapper and the kernel encryption through that. So I haven't had an opportunity to explore all the details of how it's specifically encrypted, just that it uses the device mapper and that it's not directly accessible. So it's a Linux kernel thing is the short answer to your question.
I guess because the end result basically is if you're going to subpoena Google to get access to that data, once you've made the mapping using Beacon, do they have the ability to decrypt those files? Could you subpoena those files directly?
No, you can't.
So that's like a device related.
Yes, it is. Yes, exactly. And actually the encryption keys are stored on a TPM,
Okay.
which is, they've set it up to be very delicate. Like if you try anything, it'll flush those keys and all the data is unrecoverable. So yeah, it's kind of a cool feature actually. And that's why we couldn't load like a custom operating system to pull any information off of it, because of how good those security mechanisms are.
Got it.
Yeah.
Okay, thank you.
Yeah, I have a related question.
Sure.
So to me, Beacon sounds like more like a user or device management tool instead of a forensics tool. Do you have any comment on that?
A user and device management tool?
Yeah.
I'm not sure what managing you would do with it, because it's a data collection tool really at its heart. And it's the data that it's collecting is filling gaps that you need to fill in order to do forensic analysis.
But for forensics, usually the examiner, they will extract some evidence. But here, actually, the Beacon needs at least an administrator's cooperation to install this work, right? Then you are basically, the forensic part is just to get whatever Beacon collects there. So to me, it's not really forensics.
So that's, Gripper is forensics. Beacon, you're right, there's a difference there, right? So the Beacon is just filling these gaps. Gripper is what actually does that combination of the data and reconstructs the timeline. So in a way, you're correct, but we can't do the forensics on the actual device. Those logs that are on the device are encrypted. We can't get to them, and so we need to be able to send the data to somewhere so that we can then, as you say, extract the information to then do forensic analysis on it. Otherwise, we can't make those explicit connections.
In this comment, I think anyway, Jimin has been delivering this course, like
Yep.
forensics, so he knows all the details. And your the Beacon work is you are leveraging G Suite.
Mhm.
Normally, forensics is trying to determine hidden files or deleted files from your data source, right?
Yes.
Like some devices, whatever. So from forensics perspective, we have to discover this kind of deleted hidden files. But at the same time, we have to generate some kind of good timelines. So that Beacon's work is mainly focusing on the latter case,
Yes.
how to build timelines. So that's why we are not touching how to identify hidden or deleted files from G Suite or somewhere in some cloud.
Right.
Am I
Yes,
right?
yeah, that's exactly right.
So in terms of timeline construction, it's part of forensics, but in terms of entire forensic, the tax perspective is covering only partial. So I think that is my view.
Yes, that's
So
accurate.
I have follow-up question. on
Sure.
that. Actually, there's a very important tool called log to timeline. So it has been used a lot to all the forensic examiners. So can I use log timeline with G Suite? It seems like G Suite can generate a lot of the information that I can use for log to timeline. So it can generate very efficient timeline that I can use for forensic examination. So
Right. So when I was talking about F3, the timeline reconstruction aspect of the framework, I mentioned that one of the challenges is using existing tools like log to timeline with web data, because there are all these extra metadata fields that they're not built to support. So
what if I have some kind of wrapper or some kind of the tool that I can transform?
Then yes, as long as you're okay with a partial view, because for example, some of the metadata in Google Drive includes who owns the file, if that's different from the user that you're impersonating when you're getting all of their information, all the comments and revisions and things like that. So all of that can't be captured by that kind of a tool. So if you're okay not having all that extra information,
I'm not okay. I think that's why I think
and so
the reason why I discussed this one is because of this. You are working on this time
New
construction to
environment,
Exactly.
new file semantics, right?
to achieve completeness.
New
Exactly.
operations, new
And so
everything, yeah.
That
if
should be
you
very
really
clear,
want the
so-
whole timeline, it won't be adequate to capture all that information.
Exactly.
So yeah.
Great. Right.
One more question.
Sure.
Can you explain a little bit about the legal issues involved with the evidence acquisition in this web environment? For example, the examiner, they retrieve some account passwords on hard disk. Does that mean they have the right to access the Gmail account?
So I think there are a couple of issues to consider here. So first of all, if the examiner is a law enforcement officer, then they have different privileges than if it's just like an organization administrator. So that's the first thing. So let's assume that they're a law enforcement officer. The answer is probably not, but sometimes there are cases where prompt response is more important than the cooperation of the service provider. Not my words. I'm quoting an FBI agent from Tennessee.
Depending on whether or not this is private investigation or public investigation.
Yes, exactly. So that makes a big difference, and that's one of the things that I talk about. I'm drawing a blank on which chapter it is, but sometimes these non-government organizations need methods that are only available to law enforcement, and so we need to have some kind of balance. But another issue that relates to your question is that when you use a company computer, even like the ASU computers, what's the first thing you see? You see a notice. There is no reasonable expectation of privacy when you use this device. So the reason why they do that is because they need to have the ability to get information about what you did on their device. And so I'm no lawyer, but there is precedent for giving organizations this kind of capability in the interest of doing forensic examinations, figuring out what happened when a user was misusing their systems.
Personally, I think Jimmy's question is very important in terms of usability perspective. So eventually they have to use this tool, then somehow legal aspects should be incorporated. So that way later on, forensic examiners can use it, right? So,
Yes,
right. So
absolutely.
based on different steps and stuff like that. So
Yeah.
very important questions. Okay, any other questions? So if you don't have, then let's try to give him another big round of And we will have private sessions.
You're gonna kill the
Yeah.
wave by the internet.
Thanks for tuning in.
We have to
You did some video?
streaming.
Yeah,
So
it's
we see
streaming.
your family.
Say hi to my family. Hi, everybody. Love you. Thanks for tuning in.
I gotta get some.